Hey, Jonathan. Glad you sent me a message. I was glad to see you sent me a comment back in Google Classroom. That's good. You can feel free to do that in there because I did create that Google Classroom class uh, with just you in there. So when you type comments in there, I'm the only one that'll see them. So you don't have to worry about someone else seeing that you posted a question or a comment in there or something like that. And that'll work a lot better than trying to send me an email because the spam filter is kind of wacky. Okay. So yeah, do feel free to send me questions. How quickly I'll get back to you is a question because of my schedule right now, but I'll at least that day, but it might be too late in the day for you to get it done that day. So if that happens, like I said, don't worry about it and we'll just keep the timeline moving. So with our binary numbers assignment here, the computer can only understand ons and offs on a circuit. So that means we have to use a number system with just zeros and ones, okay? And you probably read all this, but at any rate, what we do with this is we divide it up into a byte or 8 bits just for human sake. The computer doesn't care. We could send it a million ones and zeros and it can keep track of them and go through there. But basically what we do is we have this byte of bits and we're going to utilize that to represent one character when we're communicating with the computer, okay? So a basic thing to understand here is each of these bits kind of represents a decimal value too. So when it's on or a 1, that value is added to the total. So for example, if we take a byte and all of the bits were turned on, you start at the right-hand side here, and 2 to the 0, this is 2 to the 0 power. It's a base 2 system. So 2 to the 0 equals 1. And then the next one is 2 to the first, 2 to the second, third, fourth, fifth, sixth, seventh. When you go up that, 2 to the first is equal to 2. 2 to the second is 4. It basically just doubles in value each time you go up here. So when a bit is on or a 1, its value gets added to the total. So when you have a byte where all the bits are turned on, its value adds up to 255, okay? Now, that's how we convert numbers back and forth from decimal to binary that the computer can understand. So just having an example here of decimal number 183, if the 128-bit is turned on and the 32-bit and the 16-bit and the 4 and the 2-bit and the 1-bit, you add up those values and 1011011 or on, off, on, off, on for a computer, that means 183, okay? But as people, we don't communicate with numbers, right? We like letters. So there's this system called Unicode where every character in all the languages that might be used on a computer have a decimal number that represents the characters, okay? Now, ASCII, which you may have heard of, is just the English part of Unicode, or the English language characters. So on this chart here, now there's more things on here than you need. You don't worry about this hexadecimal and octal stuff here. That stuff we're kind of ignoring. What we're looking at is the decimal numbers and then the characters that they represent. And if you get, this is just, we use a lot of characters typing into a computer besides just these letters. So there's some things over here that you don't have to worry about either. But when we get over here, even a space, when we type on the space bar, the computer doesn't understand what that is. So we've designated that the number 32 equals a space. Now remember, computer doesn't understand the decimal number 32 either. And so we got to do the ons and offs, or the binary that represents 32, right? And if you're going to do your name, you have to go to the particular letter for your name, find the decimal representation, and then convert that to binary, okay? So the process is, let's say I start typing my name, a capital letter P, that actually in the ASCII chart equals a number 80. And so what we would have to do in here is turn on, let me go back up to where the values are for this. So the 128-bit would be off, or a 0, right? Because I'm only trying to get to 80. The 64-bit would be on. The 32-bit would be off. And the 16-bit would be on because 16 and 64 happens to equal 80, right? So the capital letter P, which would equate to 80, to the computer would actually be off, on, off, on, off, 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 off to get to the decimal thing of 80, if that makes sense, right? Hopefully so. So that's the process. We think computers are so smart, they're really pretty dumb, right? So that's the process that the computer has to go through. It's lucky that it's just really fast. So the computer goes through this process every time we type in a character. Here I'm going through that process trying to show you letter Z or lowercase z. So the computer can't even tell the difference between an upper and a lowercase z. It has to go through that numbering process. Now you notice here there's another byte of just all these zeros. That's because in Unicode it has actually 2 bytes because there's a lot of characters around the world in different languages. ASCII only uses this second byte of it to convert things back and forth. So basically what I'm asking you to do here is type in here your name, just kind of go down. You only have to go 10 characters. Don't forget though, you usually put a space between your first and last name, and the computer can't forget the space. I've given you an example, but all these numbers are wrong, right? You might remember I just showed you the capital letter P was actually 80. So we would put 80 here from the ASCII chart. So you look up, type all the letters down for 10 characters of your name, look up the characters, what their number representation would be in the ASCII chart, look at that decimal column, and then convert that decimal number to the binary number the computer would need to use for on-offs to understand it, okay? So hopefully that makes some sense. If you've got questions more, if that helped, hopefully that helped a little bit. If it didn't, get back to me with some more questions in Google Classroom. Thanks.